So this problem is best explained by starting with your segment addition postulate. So again, beginning to middle is u to t. So I'm going to take the u to t. And then middle to n. So from t to s. And then from beginning to end, so that would be the entire one, us. So again, let's look at, well, what, in this case, we have expressions instead of numbers. So what is the expression between u to t? Well, up here we have 5x minus 3. So I'm going to go ahead and drag that box in the first one. And then between t to s is 7x. And then for the last one, 45, from beginning to end, u to s is 45. So after this, we need to talk about, well, how do we solve this equation? So I'm going to write this equation down on the next slide. So 5x minus 3 plus 7x equals 45. So if you remember when we talk about how we solve an equation, we draw the wall, start with the variables, always variables first. So the 5x and 7x are on the same side. So we go ahead and combine them and get a 12x. Bring down the minus 3 equals 45. Then from there, we got to do the opposite operation. So the number that doesn't have the x is the minus 3. So we add 3 to both sides. We get a 12x equals 48. And then to get rid of the 12, we have to divide. So that gives me x equals 4. Now here's your first introduction into some real geometry. So in geometry, it doesn't just ask for what x is. If you go back to the beginning, we find the value of x and st. So now that we know that we got the answer of x equals 4, I need to look at, well, what expression is between s and t? So between s and t is 7. So what I'm going to do, 7x. So what I'm going to do, since it's 7x, I know x is 4. So remember that would be 7 times 4, which would be 28. So my final answer is 28.